Space is, by definition, silent, a vacuum with no air molecules to carry vibrations from point to point. In this environment, a massive explosion could happen just meters from your window, and you would hear absolutely nothing. In April 2026, the 4 astronauts of NASA's Artemis II mission traveled further from Earth than any human being in history. Their mission was a high-stakes return to deep space, pushing 470,000 kilometers away from home. Their home for the 10-day journey was the Orion capsule, a pressurized metal shell with about 9 cubic meters of habitable space. While cruising toward the moon, the crew heard a distinct, rhythmic knocking sound. It didn't match the internal hum of the air scrubbers, the click of the valves, or any of the hundreds of systems they had spent 2 years memorizing. It was coming from the other side of the wall. This noise creates a physical paradox. Every law of physics suggests that a vacuum cannot transmit sound from the outside, yet the crew sat in their seats and listened to a knock that originated in that very void. This wasn't the first time an astronaut encountered an unexplained sound. In 2003, China's first taikonaut, Yang Liwei, reported a slow, hollow knocking, like a wooden hammer striking an iron bucket. He searched every panel of his capsule, but found nothing to explain the noise. In 1969, the Apollo 10 crew heard a strange, eerie whistling while cut off from Earth on the far side of the moon. They described it as outer space music, a sound so unsettling that NASA kept the recordings classified for decades. Modern crews on the International Space Station have continued this trend, frequently logging unexplained taps and pulsing sounds through their speakers and the station's hull. To understand why these noises are so disruptive, you have to understand the intimacy astronauts develop with their machines. They know the specific hiss of every suit port and the exact vibration of every mechanical coolant pump. When a sound occurs that isn't on that mental checklist, it triggers a conflict. The astronaut's scientific training hits a wall, and a primal part of the nervous system grows rigid, reacting to a noise that has no logical reason to exist. While the vacuum is silent, the spacecraft itself is highly resonant. It is a complex assembly of metal and composites that rings like a struck bell whenever the structure is stressed. The most likely cause of these stresses is passive thermal control. To prevent one side of the ship from melting and the other from freezing, the capsule slowly rotates, cycling the hull through temperature swings of over 300 degrees Celsius. Because the hull is made of different materials like aluminum and titanium bonded together, these layers expand and contract at different rates. The metal doesn't move smoothly, it builds up tension. That tension is eventually released in sudden, microscopic pops. Each release sends a vibration through the hole that the crew interprets as a sharp knock or a groan. Engineers have known about this thermal flexing for 60 years, but the human ear is evolved to perceive a sudden knocking as something intentional, making it nearly impossible for an astronaut to ignore. The second suspect is a constant threat in deep space: micrometeoroids. The path between the Earth and the Moon is filled with microscopic fragments of rock and asteroid debris. Even a particle the size of a poppy seed carries immense kinetic energy, traveling at 20 kilometers per second. Upon impact, it instantly vaporizes, sending a shockwave through the entire structure that sounds like a loud bang inside the cabin. The third possibility is located inside the ship's own unpressurized compartments. A propellant valve clicking open or a cooling pump engaging in an external service module can transmit a vibration through the structural frame. To an astronaut trying to sleep, these mechanical actions feel like a deliberate tap on the wall they are leaning against. While these explanations cover almost every anomaly, mission control rarely has the specific data to confirm which one caused a noise after the fact. The astronaut is often left with a list of probable causes, but no certainty. The Artemis II crew only had to live with these sounds for 10 days. A future mission to Mars will require astronauts to spend up to 3 years inside a ship that never stops making noise. Over a long duration, unexplained sounds become a psychological hazard. They degrade sleep quality and breed suspicion, making it difficult for a crew to maintain their grip on what is real and what is just the ship settling. To study this, space agencies run analog missions, locking crews in simulated habitats like this underwater research station for months at a time. These studies show that when crews can't explain a sound, sleep cycles fail and minor interpersonal disagreements escalate into major conflicts. The most resilient crews are those that develop a habit of naming every noise out loud, immediately filing them as known events to prevent the mystery from causing a breakdown. The enduring challenge of deep space involves training the human nervous system to coexist with a machine that speaks to itself. Future crews will have to accept that in the silence of the void, their ship is the only thing that will ever